Okay, good. And
Thank you.
Tony's already there. Oh, we're live. So, where's the MC? Let me just find out if we're supposed to start.
Still work?
Well, good evening, everyone. Thanks for joining us. You know, when we talk about the industrial IoT, there are usually two archetypal cases, two big stories that come out. And it's a little bit cynical that today we're still having only two good stories when it comes to industrial IoT. One of them is predictive maintenance, and I think there are kind of conversations around predictive maintenance in the presentations and the floor. And the other use case is connected cars. And the way the story usually goes, it starts with, you know, cars generate petabytes and zettabytes or whatever fancy metric you want to use for data. And what we want to do today with the panel and with your participation, hopefully, talk a little bit about connected cars, autonomous cars, about the data that they generate. Why is it important? Is it really true that they generate so much data? But why is it important? To whom? What is the business model that we can build, or business models we can build based on this data that we have? My name is Joe Barkai. I'm an industry analyst. I write about technology topics. And primarily, I try to understand, big word, the future. But the future is what will happen in 5 or 10 and 15 years, not 50 years. And a plug for myself, tomorrow morning at 9, I will be talking about the world in the year 2030. So what will the world look like in 10 years or so? And I'll moderate the panel today, so it's really not about me, it's about the panelists. And I'll ask them to introduce themselves one at a time, and then we'll go to the questions. And what would be extremely useful, and I hope much more interesting, if you have questions. So feel free to raise your hand. I'm not going to be able to see you anyway, but stand up, and there's a microphone, or step up to the microphone and just ask a question. It could be on topic, off topic, could be different opinions, but let's have a conversation as opposed to a formal presentation style discussion. So with that, why don't the panelists, you want to start introducing? What's your name? What do you do?
Oh, okay, sure. So I'm Thomas Wilson, and I'm the VP of Product Management at GraphCore. Maybe just introduce the company just a little bit,
sure.
if that's all right. So GraphCore is an AI processor company based in the UK. And we recognized the need a few years ago for really a completely new kind of processor architecture for the processing requirements unique to a machine intelligence problem. Mostly focused with data center and cloud AI and the kinds of AI processing that happens at that scale and sort of hyperscaler type of environments. But it also became very clear to us that the autonomous vehicle is to a certain extent kind of a data center on wheels. So we saw certainly an opportunity for very high levels of machine intelligence processing within certainly level 5 robo-taxi kind of applications. And we'll be talking about that more as we go along probably.
Alex?
Thank you.
All right, I'm Alex Andersoli. I'm a senior analyst at Dell Technologies. At Dell, my main role is try to figure out what's going to happen over the next 3 to 5 years and try to build a consensus at Dell towards how we're supposed to move forward. While my role isn't specifically on connected and self-driving vehicles, we do deal with it at Dell Technologies because those things are generating zettabytes of data. That data is going to have to travel, and whether they go to a one of our storage boxes or to AWS or another of those things. It's something that we and especially our customers have to think a lot about.
My name is Klaus Scharf. For 31 years, I was working with Volkswagen, and at the moment, I'm in the process of retiring. So this is about the last thing I will be doing as a Volkswagen employee. But I'm already on vacation, so it's kind of funny. But I know if you said, what is the future looking like? In 2005, just came back from California, where we had built up the Volkswagen Electronic Research Lab, and one of the things we started then was Stanley, the first driving car. And this is now 14 years gone, and at that time, we thought that we had built some interesting technology there, but the people from marketing, they were also very interested in what we were doing. Then they said, well, you have spent $2 million on this project, and it was worth like $70 million in advertisement, and so great job. And we said, but what about technology? Come on, nobody believes that this will ever happen and be on the road. And when we think about what's happening now, things will be completely different in 2030, probably from what most people now think. So even if we think now there will be automatic driving cars, maybe they are flying in 2030 or whatever, but it will be different than we are thinking of.
So let's start with the basic premise that autonomous cars or connected cars generates zettabytes of data. Is this true? Is it a problem only of volume or something else? Why is it so important to talk about it? Storage is not really a problem anymore, is it? So why are we so excited about all those data that is being generated? And maybe kind of, as you respond to this, is it not true that much of this data, and this is from a car maker company, much of this data is transit anyway. It generated, the ECU uses it and dumps it. So why are we so excited over this data?
Number one, we already know that if you own data, you can make a lot of money with it. And the other point is the automobile companies have noticed that other companies now are making money with these data, and they are afraid that they could lose this market. And so that's why they are jumping on this.
Let me ask you again, and then we'll come again and jump in, please. Much of this data is useful, the way I understand it, only to the OEM, telematics, engine performance. So why is Dell so interested other than maybe providing storage? So is there something else in this data that has value, or is it only between the car and the car maker? Any thoughts?
From Dell's point of view, volume is admittedly part of it. A zettabyte is, to give a sense of comparison, a zettabyte would be, I'm trying to remember, but it's like if the average HD movie is about 2 gigabytes, that would be, a zettabyte would be 500 billion HD movies. In terms of storage racks, you would need 67,000 of our racks to hold a zettabyte of data. If you decided to go the cloud route, that would be about $64 billion a month on the Google Cloud. So,
and then how long does this data need to be maintained anyway, if most of this data is used for operational vehicles?
That's another interesting question, because, as you say, some of this data is only interesting to the OEM, although the fact that it only matters to the OEM means it may not mean much to, say, Dick and Harry, but it's going to be very interesting to VW. And the question, of course, you're right, though, that we're all trying to figure out not just how long is this data going to be useful. It's like, if you have a pothole in Cambridge, you need to know, do you need that data to go all the way out to Boston? Or can you hold it in Cambridge for a day?
In Cambridge makes no difference, and I'll never fix it anyway.
Fair point. So it's like, it's not just a question of like, how long will you hold on to said pothole data? It would also be a question as to when it would get there. At this point, it's like, even with 5G, the fastest way to get the terabytes, if it's as small as terabytes of data off of that car, is not to put it through a 4G or 5G network. It's to take the hard drive out of the car and put it in the post and mail it to your data center. Not email it, put it through the snail mail. Because it just takes a lot of time to get that data in and out of the vehicle. Volume is still very important.
Okay.
Yeah, there's huge value to that data, and it's my belief that, I mean, one of the main reasons why Google even bothered with a self-driving car is to get hold of that data, right? And most of the money probably from self-driving cars, which are extremely expensive to develop and deploy and manage fleets, is to get that data. You also need, the data sort of feeds the whole process in that you need to recover that data for training, so that you can continue to develop new AI models, new autonomous vehicle models, not just develop new models, but make the models you have more accurate, because the more data you feed, the more accurate they get. Also, if you want a more accurate artificial intelligence model, you need a bigger model. And by bigger model, I mean more parameters. The more parameters you have, the more data you need to feed it. So the bigger the model, the bigger the data. So you need to be harvesting the data from the vehicles that are out there to basically help invent better vehicles by feeding the algorithms more and more data. But I mean, at the end of the day, you still need to process it, and that happens in the vehicle. And the amount of data, I haven't looked at the kind of function that this follows, but I'm willing to bet it's exponential in terms of the amount of data that's getting generated by ever higher resolution cameras, HD radar, higher definition LiDAR, the amount of data that's being processed that's going up. So that's continually to exponentially increase the compute requirements. And if that was, everything else was constant, that would be still hard. But then the models are getting bigger. And unfortunately, as you increase the number of parameters or weights in the filters in the model, call it N, the compute complexity increases by a factor of 2 and change. So your compute requirements go up, certainly for training. So bigger models means higher compute requirements, and this is really sort of pointing towards fundamental changes in the processor architecture. You knew I was going there, right? In the processor architecture that's required. And also not just that, but the model architecture. The models need to become sparser. And increasing sparsification is more challenging for conventional processor architectures.
So to be fair, I think it will be fair to say that we're still within the OEM ecosystem. Is between the OEM and maybe the fleet is the data. Klaus, is Volkswagen thinking about other uses of data, any sort of data generated by a car, outside of the telematics for maintenance and operation?
The biggest problem at the moment is all these new technologies going to the cars, like autonomous driving. How can we live with this? How can we bring this to the cars? And this is a real difficult thing. Just imagine if you bring software to a self-driving car and there's a bug in there. You don't want to wait until this car goes back to the dealer. You need to repair the software as soon as you know that there is an error. So you have to deal with this kind of data as well. Yep. And then you have to prove to authorities what kind of software was in the car at any certain time. And there will be changes in the future with regulations where every car company has to do this, no matter if it is an automatic driving car or a normal connected car. You have to prove what kind of software is in the car, and you need a way to deal with this and to deal with all the information you have yourself, or you should have yourself. And that is just before you have to deal with all the additional information which comes from the car.
Mm-hmm. Again, if there are any questions, please just shout out and we'll address it. So let me add, from my experience in the industry, what other sources of data exist and why OEMs and others are interested. Think about the data that provides insight about driving habits. Insurance companies offer new policies based on your driving behavior. Think about the location you are at, where you stop, where you refuel the car, what you buy. The concept of a car as a center of the universe, the car as your wallet, is something we're very interested in. So all of a sudden we realize that not only does the car itself generate information, not only sensors in the car, but we as consumers generate data all the time. And what Google and Facebook and other companies really, really interested in that. They already don't care much about cars, but they want to be completely throughout the day connected to me. They don't want to let me go anywhere, whether I'm in the car or not, whether I'm renting a car, I'm driving, I'm in a train, they don't let go of me. And that's the sort of value of the data. So this brings us to another question. Alex, you gave the example of potholes. Who owns this data? Can the car kind of share the data willy-nilly? So if your car reports a pothole, we know you were in Cambridge. Is that okay? So do you have any kind of thoughts and experience from how companies treat the data? Is it, does it belong to the car maker because the car generated the data? The driver, maybe the owner? How do we deal with that?
Generally speaking, if you look at the connected vehicle, a lot of us have contracts with companies like OnStar, which is generally a GM company. Ford has their own version. I think Hyundai has Genesis. Uconnect, I believe, is Chrysler. If you look at their stuff, they'll generally not mention ownership at all, because for the most part, they're not that its ownership is useful, but they want to license out your data. And while some may say, we'll anonymize the data, or we'll be careful with your data, we promise everything will be fine, in many cases, they just won't say what data they will be licensing, with the general understanding that they will license all of your data. Well, all of the data on the car. It's not like they're going to get into your phone theoretically, or, well, it sounds a little paranoid, but generally speaking, the data will, most, if not all of the data that's going through these cars are being licensed out to the OEMs themselves, at least through these connected car services.
So they made that determination. They never asked the customer if they agreed with it or not?
Oh, they asked you. You just clicked yes to agree.
Yes. Mm-hmm.
Yeah, I know that's a little on the dark side.
Yeah, so I think there are some obvious uses for the data in terms of various kinds of contextual user services that can be rolled out so that they know where you are and what ads you're looking at, what stores you're driving by, things like that. That'll all get used for various kinds of helpful services, right? But to a large extent, I don't think it's completely figured out yet exactly how that data will be monetized and mined after the fact. And I think when you start talking about the importance of 5G deployment to help underpin the various kinds of connected and autonomous vehicles, you start looking at the 5G base stations, and they're less base stations, and they're really more like data centers, kind of mini data centers at the edge, where you'll have OEMs that will probably share space within that kind of 5G data center with data flowing by each other. So it's the whole sort of supply or value chain in terms of the operators and the folks like Ericsson and Volkswagen and the car makers and how they all cooperate as part of managing that data and harvesting that data. It's interesting that it's not completely figured out.
And I think the ecosystem is broader than that. So it's the car makers and their suppliers. Okay, that makes sense. If you have a fleet, it's the fleet owners. But what about retail operation, the gas stations or the charging stations? So we have a growing ecosystem, and they all contribute the data, and they would all love to get a piece of this data. So should we get paranoid?
Yeah.
Yeah.
One out of three said yes.
And these guys will, yeah.
But not only for the automotive market. I think it is everywhere.
No, that's true. I mean, I think that the sense of loss of privacy when it comes to our data is true. I mean, we all walk around and we do stuff, and we leave digital footprints behind us, and we can never erase them.
And
we can say,
like all kinds of innovation, they can be used for the power of good or the power of not so good. And so there needs to be policy, and good policy is driven by a certain amount of paranoia. So I think it's good for the consumer to understand the amount of information, contextual information that is generated in these kinds of vehicles and how it's being used, so that, and they should understand the T's and C's that they click OK for to know where it's going, because there's a lot of information about, well, all of us.
and of course, there are other interesting corner cases, such as what happens in the case of an accident. Does the police have the right to access the data? Or if they track a criminal, by their definition of criminal, do allow it to do that. And the precedent says, yes, they can attach a GPS tracker to your car in the US or so.
I think it is a little bit more than just checking I allow somebody to take my data. If I would only see this, I would probably not give my data away. So there must be a little bit more, and I think that is what all the car companies are working on, so that it is a positive tit for tat. And so if I give my data away, I want to get something. Be it that the car company offers me the charging price. I'm not talking about gas or diesel anymore. I'm talking about charging at a cheaper price, and or the insurance, it is included at a cheaper price than anybody else can offer me. So this is the price for giving the data away. And if you, and then there come other things. Most car companies have seen that they miss this thing with the platforms, and the platforms are already in the hands of the Amazons and the Googles.
And the Blackberries.
So we have to find a way to come back in this area, and it is very hard to do this, and that is why a lot of the car companies think that they need to cooperate, or as I would like to say, co-opetition. So we need to come up with standards for all the data, so that everybody can use the data, can build up new mobility concepts, mobility business ideas, which somehow fit together, but where we still keep our customers and have our customers, but then we can use the business models from outside in a little bit as Apple did when they started their ecosystems. And so this is where we are coming to, what is in the near future, that we will not have the platforms alone, that there will be a Volkswagen platform, a Mercedes platform, a Toyota platform, but there will be platforms of platforms. There will be a platform where all these other platforms can log in, and then they can exchange these lots of data.
How practical is this today because of incompatible semantic models? So you have two data sources that exchange information in an unknown standard. I mean, yeah, there's 5G and so on, but once you get to the data, how do you deal with incompatible semantic or non-existent semantic models to get this kind of collaborative? Yeah, of course.
Yeah, okay. It's very easy. If we, for example, if we have smart cities, if Volkswagen goes there, hey, we have this fantastic system, you should implement this into your smart city. Then Hamburg, Berlin, Paris say, wow, great. Then next week Mercedes comes, then comes Toyota, and they would say, hey, are you guys crazy? We can implement one, but not more. So there is an absolute necessity to come up with these standardizations. Otherwise, all these business models will not work. And I think most of the companies have seen this, and they are working on these standards.
So you're saying that an industry that refused to change over 100 years now all of a sudden get together and agree on standards and data exchange?
Our enemies are not BMW or Mercedes. The enemies are GAFA.
Yeah. So I know, Klaus, that you're interested in, and then we can come back to the topic if you want. You're also interested in distributed ledgers and blockchain. How do these new technologies and new approaches help address some of these issues around data governance, dealing with privacy, that is a big deal, and maintaining integrity of the information?
So with this, it becomes possible for a user to exactly say what kind of data he wants to offer to someone and to be used by someone else. So he or she has the opportunity to manage the data. Does it go to an insurance? Does it is it used for paying charging or paying other things? And so with this, we have an opportunity for data management. When you have the data management, then you also need to know how is some kind of an automatic transaction happening, and how can I see what kind of transactions happened, did it happen right? So I need a way which is tamper-proof, and I can always check what kinds of transactions and data exchange has been happening. And so we can use this, the technology blockchain, perhaps also for payment, but much more for to prove what kind of transactions actually have happened, and then again what kind of software, for example, has been going to the car. And for this, we have done already several proof of concept. So I think most of the car companies are working on these things, and the introduction of these things is just a matter of time over the next 2 or 3 years.
Alex, any thoughts about data security, data governance? Is there kind of a model that says maybe Dell, with permission of course, can leverage data and move from offering only storage to offering added value? I mean, it's a loaded question, but.
It is a loaded question, and when I'm not sure if I'm qualified to completely answer. We do have quite a few, I mean, our stuff is supposed to be secure, otherwise people wouldn't necessarily store stuff on our storage devices. We also own a few companies that import for identity access management, like RSA, and cybersecurity, like SecureWorks.
Mm-hmm.
So they can probably speak a little more on terms of what Dell and its family of companies can offer in terms of cybersecurity and such. And we're doing some work in terms of data we're currently in the process of figuring out, actually I'm not sure. Please move on to Mr. Wilson.
Just to take sort of a different tact on this, from my perspective, it's too much data. And really, when you think about it, like I was saying, the amount of data that's being pulled into the car via the various kinds of sensors is going up. The number of cars is going up, and the size of models is going up. And even with all the sensors and the amount of data that's going, so I was just reading, so something like about 100 terabytes-ish per 8 hours, that order of magnitude. So it's maybe like 100 petabytes over a year, roughly. Somebody recently estimated that the memory capacity of the human brain is something like 2.5 petabytes, as compared to 100 petabytes that we pull in through one vehicle per year. And yet the human brain, I mean, I used to actually, before I was in AI and worked in automotive and semiconductor, and before I did my PhD in plant biology, I taught people how to drive. I worked in my 20s, I worked for about 3 years as a driving instructor, and it's really interesting to compare teaching a human how to drive versus teaching these machines how to drive. And so the human is going through supervised or unsupervised learning for probably a decade and a half, accumulating all sorts of information and data about road conditions and driving scenarios. They watch their parents drive. It's a huge amount of training data that we still haven't even come close to with what we're trying to do with vehicles. And all of that's stored because it's stored very, very sparsely. So somehow the human brain is able to reduce it down to the bare essentials information, and we don't know how that works. And the way we process it is very sparse. Also, when you think about the sensing, a human gets into a vehicle to learn how to drive, and they have one camera. It's a binocular camera facing forward that they can supplement with this thing called peripheral vision, and they got their ears. So it's a very incomplete, imprecise data set that they build a situational awareness from. Doing that from much sparser data than the brute force approach that we take with AVs. So there needs to be really, I think, a fundamental approach with taking sparser approaches to processing, sparser data, so that we can manage. I think the human brain's about 10 watts, and it's taking kilowatts to actually do the processing in these vehicles, and it's still not doing what it needs to do for what you might call a complete L5. So the data is valuable, but we've got an exponential growth in data that we need to process, an exponential growth in models to actually process it. So something needs to happen in terms of the way we approach the problem.
Although, you know, the comparison to the human brain is always interesting, but remember, every year in the US, about 30,000 people are killed. Worldwide, every year, 1.3 million people are killed by humans. So maybe we should change the point of reference. Maybe we should strive for better than that, because again, the bar is fairly low. 1.3 million people are killed every year.
Yeah. Yes, but it's many more cars with people in them than with machines.
To build a bit on the what cars can perceive versus what humans can perceive, it's not just what are the cars collecting themselves. They're also collecting data from other cars, from infrastructure, etc. So it's not just we see clouds coming on the way, we think there's going to be a storm. It's going to be a bunch of cars seeing the same thing, and they're collecting data on what that storm is going to look like, so they can warn cars further down the road to move away. Even if we don't reach L5 or anything like that, full automation, these cars can still give warnings hundreds of miles away to make sure that everyone knows what's coming up, whether there's some issues with the road sign, what kind of if there's traffic and that everyone needs to move away, etc., etc. These cars are checking on each other, not just checking on themselves.
Right, and it gives you a better perspective of the entire traffic. And as we said earlier, the question is, do people feel there's an invasion of their privacy and so on? So it's an open question, it's a fair question. At the same time, if you see participation in ways, and people essentially report on where they are, maybe you say, well, people are altruistic enough for some of them to report.
And there's different kinds of data that's beginning to evolve too. And I was just reading a quote from Brian Selesky, who's the CEO of Argo, who, whenever I read things he says about this marketplace, I always find extremely pragmatic and very rational. And he figured we're about 80% of the way there towards true L5. And really what we've managed to crack is mostly the perception problem. So it's all this various kinds of sensor data, and that's what we're really talking about. But the next 20%, which is going to be tough, is where the machine, because it's not a driverless car, there's a driver, it just happens to be a machine, where the machine needs to begin to anticipate, to look at the entire sort of semantic context, the context of what's going on around it, and understand the intention of the drivers. This is something that humans do by making eye contact and looking at various kinds of body language, even body language with the vehicle itself. You can sort of anticipate where things are going to go. That extra 20% is going to be really tough. And that kind of processing, you're beginning to see in things like natural language processing, new kinds of transformer models that don't just recognize words, but understand the entire sentence, regardless of where the words are within the sentence, understand the entire context and the intent and the sentiment even behind the sentence. And that kind of, see that sort of evolving towards natural driving processing, where it begins to actually sort of pass the Turing test in terms of you can't tell whether you're actually driving next to a person in that vehicle or a machine. And those kinds of models, those NLP models, are huge.
This is a far look into the future, what's coming. That is at least 5, maybe 10 years away. That is always difficult to convince someone because you can believe it or you don't believe it. I would rather come up with an example which almost everybody can imagine and which is very, very easy to do at the moment because we could bring this up in a serious production tomorrow if we wanted. And that is the simple case of odometer reading. So 10% of all the cars, at least in Europe, have a faulty odometer where somebody tampered with, where somebody did something wrong with, and that makes it difficult to, or that comes up when you try to sell the car. Do the people believe that the car really has only 50,000 kilometers, or is it rather 100,000? So that influences the price of the used car. So everybody can imagine that this, if we know exactly what the odometer reading would be, that would help some people. So here another example, if you write each time we put the car into the garage, the odometer to the blockchain, we can really prove, and nobody can take that back and change it anymore, so that from that point of view, you have a direct advantage by putting your data in a blockchain, in a distributed ledger, whatever. And from that point, if you start with something small, people start to understand what you're doing. If you overwhelm them with new technologies and new ideas, they may probably say, no, not with me. But if you give them a small advantage time by time, then this could work. And that is also something a lot of car companies and also tier 1 suppliers are working on. So starting with something where people understand where their advantage is.
And I just wanted to complete my thought. That's a good point. There's all sorts of data that can be collected at different scales. And where I was going with what I was saying before was when you go beyond the sensory data of what the vehicle has to all the metadata that it generates about intent and driver behavior and the behavior of drivers around it, then that's very interesting data that's being collected that has a different kind of value.
You used the term situational awareness earlier. It's the context. But it's interesting because we all envision this high level of automation, level 4, level 5, level 4.5, etc. But simulation shows that until we have significant amount of autonomous cars on the road, we're not going to see any impact, any improvement. And it's high. I mean, it's intuitively, well, we have to have few. No, simulation shows that you have to have at least 50% penetration rate in order to see meaningful result in terms of improving in traffic, reduction in accident, and so on. And it takes a long time to get to this level of penetration. The rate in which we buy cars, autonomous and others, is fairly slow. And I fear the day when we have a mix of smart cars and stupid drivers on the road. And you referred to this earlier.
That's the problem.
Part,
it's a lot easier if you just make a clean cut and they're all machines because they can talk to each other over 5G and make use of the infrastructure to coordinate, that they can platoon, and they're all sort of talking to each other using the same kind of machine language. Throwing humans into the mix or mixing up those two populations of drivers, that creates trouble.
Right. Which is why perhaps geo-fenced applications are a better way of going about it. Alex, you were going to say something?
Yeah, it's worth noting that autonomous vehicles are already with us. There's at least one claim that there was an autonomous vehicle made in the 1980s, the main problem being it couldn't really be on the same road as other cars. But the autonomous cars you do see, and by cars I mean vehicles, and you'll see why in a second, are being used by organizations by Rio Tinto in very restricted circumstances. It's like in the United States, I think a lot of companies are trying to focus more on, say, federal highways and such because there's too many regulations among, say, the average residential area. So it's like, and then there's the whole question about how to convince humans to surrender manned cars, at least on federal highways. It's like, I'm just trying to imagine what that debate would look like. And if you try to have it sometime over the next 10 years in the United States, you'd probably be more likely to see self-driving cars being banned on public roads. You're going to see them on geofenced a lot earlier. Sorry, you already see them in geofenced.
Yeah, the example of Rio Tinto, actually there's a better example, which is airplanes. But the autonomous airplane is so much easier to implement than an autonomous car on the highway, which is why, again, mining, Rio Tinto is a mining company, would be a good application, geofenced applications. I think we started the wrong way by, Silicon Valley mentality. Build the car, put it on the road, see what happens. And you have to remind people, this is not a Windows bug. This is a car that can hurt people.
Yeah, and I was just reading recently, and I don't want to sort of slam anybody, but just reading about the recent, and it's public, but there's recent deployment of version 10 of the Tesla software load and Smart Summon or something like that, and people are already posting. This is public. I just saw it, but they're posting on social media. It's creating a certain amount of havoc within the parking lots. They're driving into garages and things like that.
Visitors. Please note that the IoT Solutions World Congress is now closed for the day.
Okay.
We look forward
The doors
to
are
seeing
locked.
you
You can't
again
leave.
tomorrow.
Yeah, we're fine. We have 6 minutes.
We have about 5 minutes to go, and if you can stay with us, it'll be great.
So just on your point about just quickly deploying things just to try them out is an interesting approach and can create some issues.
Yep. So back to the data. The topic here, of course, is data. So we talk about the application of these data for AI-based learning model for operations. On what other tools are there, analytic tools and others, to use the data that these cars are generating, or is it only for operation, only for self-driving? Anything? So it's back to the question about what is the ecosystem? Is it primarily the OEM and the car? Is it more?
Well, while a lot of the data would be primarily useful to the OEM, it wouldn't be solely useful to the OEM. A lot of that vehicular data being used to check like how fast is it going, how are the brakes working, that's also useful to suppliers and specific uses. Law enforcement agencies, of course, will be very interested, but sticking to the more corporate side of things, advertising firms want to know when are people going to be most attentive. So it's like maybe a billboard would be more useful here. This song, when people play this song on the radio, people are more likely to change the song. Definitely a lot of mapping software, and it's going to be generally useful to a lot of different people, a lot of different organizations.
And I
I think a lot of possible business models have not been invented yet. Just an example, if you are on a crowded highway, your navigation system may direct you on another route. But everybody from at least the same company will go on the same route, and you will have the next crowded road because everybody is going in this.
It is happening. That's not prediction. Waze is very smart about finding crazy routes.
So will it be?
I'm sorry, I need to complete the story. So Waze routes them through side street that used to be quiet, and now they're. So what the neighbors did, because what Waze is doing is totally illegal, what the neighbors did, they called the police. They called to report accidents, and they were not there. They reported speed traps that were not there. Free speech. Waze can do that, and the neighbors can do that.
But maybe
Sorry.
a solution would be that everybody would get their own personalized route. Number one, because you are driving there, and I don't know, your son or your daughter is living there, and you could just pass by this road, and you go there all the time, and then your navigation system says your place is probably this road, and you can stop there if you want. And even. In this case, everything would be personalized, and these personalized things will be the thing of the future. And we have not come up with the business models yet. I don't know if that we would pay for something like this, or if some shops would pay that you have to pass them by or whatever. But there are some opportunities which are not thought about yet.
So, and again, I get back to behavioral context. If you think about how AI processing is used on the cloud right now, it's to track human behavior, what they look at, why they look at it, various kinds of sentiment analysis. Even now, just for level 2, level 3, there are driver awareness features built into cars. It's an important part of the whole process to understand the awareness state of the driver. But that's going to become more about sentiment analysis, the behavioral state, the emotional state of the driver. That's going to be important for personal assistants that are being used, but also just to track the way the driver reacts to various kinds of driving conditions, but perhaps apply some sort of AI processing to control the driving conditions that they're exposed to, or just for advertising or things like that, or whatever. So that data will be used to provide new kinds of AI-powered services to the human occupants of those vehicles. Will have a lot more time on their hands, given that they're not driving most of the time.
Yeah, I think that within 5 or 10 years, the wealth of information from multiple sources, with the occupants of the car itself, the environment, and so on, will allow advertising companies actually to predict behavior. So they'll know what you will do if this happens. Starts raining, they'll know what you'll do. And it's not that hard to do. It's more a question of data and question of data privacy. But algorithmically, we can predict behaviors. Now we have models of humans, human behavior, car behavior, and we'll be able to predict behavior, and that will be the power and of these systems. We'll probably have to give up privacy, but I think overall we're probably going to like it. We have about a minute and a half, so I want to ask just one quick question. We talked about changes that are really, really very profound, both for us, but also for car makers. Car makers that come from industry that is over 100 years old, never was open to those kind of behavior and changes and collaboration. How well do you think these companies will weather the storm, if at all? And will we see Google or Tesla being the new leaders in the industry?
I'd like to take a shot at that first. I think it's players like Volkswagen, Ford, and what you might call traditional OEMs that will actually end up owning this market, because they have such an entrenched base, such an understanding of what it takes to implement these kinds of it's not just the car, right? There's a communications and applications infrastructure that needs to be built around it. That's a huge enterprise that will take huge partnerships. I think they'll end up, there are some leaders that have sort of forged the way and sort of showed what's possible, but I think it's the big players that will take over.
So I think that traditional big players will continue to be the heavyweights of the industry. Alex?
That sounds like a politically explosive thing to ask a company that has customers on both sides of the debate.
So you don't care. That's fair enough.
I don't know if all the big companies of all the old mobility companies will survive, but the thing is, it is very difficult to turn them around. They are big tankers. But if you happen to move them around, they will go with all the force in the right direction or in the wrong direction. So if you turn them into right directions, they will survive, and they will tank down everything which is in their way. So if this happens, yes. If they take the wrong turn, they will go, or they will drive into the wall.
Excellent. So our time is up. Thank you so much for staying with us. I think we did a great job because we answered all your questions. You didn't have any. So that's probably good. Thank you so much for the panelists. It was great. Appreciate that.